Well, hi everyone. Welcome to Practical Data Science. I am Zico Coulter. I am in faculty here in the Computer Science Department, and should be a fun course. I guess it's a pretty popular, at least the first lecture. That'll shake out a little bit. What's happening this time is that there's an online-only section, and for the first lecture, they can come after the start of class, and so this is probably why it's so full. It will not be this full every time. Don't worry. It won't be a fire hazard. The reality also is that with online courses, when there are lectures online, people tend to come in varying degrees, though people that are in the A section actually are required to attend. I'll get into that a little bit more later this time around. Okay, so this is the introductory lecture. I want to talk a little bit about what data science is, what this course is all about, and what you will learn in this course and through the process of doing the assignments in this course. So, as a quick outline, I'm first going to talk about what data science is, because I think even that is not clear always in a lot of different settings. And then I'll talk maybe actually even more about what data science is not, because I think oftentimes data science is best defined in terms of what it is not. Obviously, it's a popular term right now. That's why these courses are so well populated. But I want to define what data science is and is not as far as this course is concerned. I'm going to have a few examples of data science. I'm going to give a few examples of sort of the spectrum of data science projects, or data science, projects is a good word, I suppose. And then I'll cover the more sort of logistic stuff about the objectives of the course and the course logistics. Do feel free to raise your hand. This I'll try to be, it's hard to be interactive in a class this size, but I'll do my best to try to answer questions as they come up. So feel free to interrupt me if anything isn't clear. Okay, so since we're teaching a data science course, I figure I should start off by defining what data science is. Because data science is not a term, it's a relatively new term, and it's not one that sort of has a clear definition across different fields. If you ask me versus a statistician, you probably get very different answers. So as far as this course is concerned, this is a reasonable definition. I'm not going to use it. I'm not really going to be concerned about definitions for the most part, but it's a reasonable definition. And that is that data science is the application of computational and statistical techniques to address or gain insight into some problem in the real world. And the three sort of key tenets here are the words computational. So data science involves algorithmic processing, right? It's not just about sort of math you can do by hand with a small number of data points. It's about some sort of algorithmic processing. It's also statistical, so there is some amount of analysis of data and sort of understanding and drawing inferences from data. And the last thing is this real world notion, which is actually equally important. So I think a lot of work in fields related to data science, like machine learning or AI, kind of are agnostic as to whether they're actually dealing with things in the real world. And at least as far as I'm concerned, data science really is about making inferences about the world, finding some sort of truth in the world, right? We're doing science when we talk about data science. And so we should be analyzing some phenomena that actually occurs in the real world. It should not just be some simulated data that we could create from nothing. So those are kind of the key tenets of data science as far as I'm advocating for it. But in another sense, I think we could kind of call data science the sum of its different parts, right? So data science involves techniques from statistics, from data processing, from machine learning, visualization, business analytics, big data, all these things. And I'm actually fine just calling data science kind of a grouping term that we use to jointly refer to all these things. Right? And that's actually, for the most part, as you can probably tell if you look at the course website, this is kind of the tact we're taking with this course. We're trying to give you a broad overview of different areas here to give you a sense of sort of how to approach data science problems. But of course, I'll get into this more later. The last thing, of course, is that data science is very popular right now. And so this is a maybe a few years old now, but this was a survey run by the job company Glassdoor. And actually not a survey. I think they actually they did some data science and tabulated their actual job advertisements and things like this, and information people put in about their starting salary, stuff like that. And they found that data scientist was the #1 job in the country right now, which actually I think seeing data science postings and actually having worked in the industry for a little while, on sabbatical for a while, that seems actually pretty accurate. There's a lot of excitement about data science. Though I should say that the second most popular job is tax manager. And I don't think there's be as many people in a course on tax management if it was offered here at CMU. So maybe there's something more than just the appeal of data science positions that are making people excited about data science. So having said that, and this is going to be a very, of course, high-level course or high-level lecture. There's going to be much more detail in future lectures. I do want to talk a little bit about, having defined data science in such broad terms here, I want to talk about what data science is not, in my opinion. All right, so what data science is not. And the first thing I want to say, and this is maybe coming, I do work in machine learning. That's actually my area of research. And so the first thing I'll say is that data science is not machine learning. Right? Of course, data science involves machine learning, and there really should be it was not just machine learning for all these things. Machine learning, of course, also involves computational and statistical methods. But traditionally, machine learning, there's sort of two things going on here. The first is that machine learning, at least a lot of it, does not care about scientific questions. Right? It cares about predictions and sort of accuracy of predictions. It doesn't really care about finding some true insight in the world. Not all machine learning. Some does. Of course, but not all machine learning really cares about finding some truth in the world. We care about making predictions in machine learning, however those may be. We don't really care how the predictions happen, and we don't care about necessarily inferring a truth in the world. There's also a big focus in machine learning on sort of fancy algorithms, right? Machine learning is an algorithmic field. In my research, we develop new algorithms. That's kind of what we do. But the reality is that oftentimes to do really good data science, you don't really need new algorithms. What you need to do is you need to do clean application of the algorithms that already exist. And that is sort of a big differentiator between machine learning as a field and data science. The other figure I like to show here is kind of a very rhetorical but still useful breakdown of the world of problems we would like to solve. Especially these two percentages are very, very approximate here and not meant to be real. But when I've seen problems, kind of both from an academic standpoint and in industry, there are a lot of problems that, say, businesses would love to be able to solve. Right? That's the universe of all, say, even machine learning-like problems. There's problems where you're trying to predict something from data. And don't worry, we'll define machine learning much more later on. I'm just sort of throwing out these terms here in case, at a high level. But there are, say, forget about even the word machine learning there. Just think about business problems you would like to solve from data, right? So about half of these are unsolvable, just full stop. There's just no signal in the data. I would like to predict the stock market price tomorrow using data from Twitter. Okay, people have actually tried to do this. They've claimed they can do it. They can't. That's been well established after the fact. But I would love to be able to do that, right? I would get really rich if I could predict the stock market tomorrow from Twitter. But there is no signal in the data that actually does that. Or if there ever was, it's since been mined out of existence by people that are doing this much more intensely than me. And so you probably cannot solve that problem using your data sources you have. Right? So now of the other universe, of the good universe of solvable problems, say I want to predict whether some component in a big manufacturing machine is going to fail. I'm going to do it based upon vibration data in the system, right? That seems actually much more feasible, something you could do. Maybe 5% of these really require state-of-the-art machine learning. This is, the latest and greatest in deep learning advances and stuff like this, right? The rest, the other 45%, can perform pretty well with basically simple algorithms. Now, this slide is actually one that I'm kind of changing as I adapt my own philosophy, I admit here. And I think this slice here is growing, so maybe it will eventually grow to encompass everything. People are actually seeking out problems that fall in that slice. So a lot of problems with visual data, for example, do fall in that slice. But for the most part, when you had just sort of normal column data, like a spreadsheet, you can typically do it. That's a big spreadsheet, I guess, but it's sort of spreadsheet-like data. You can typically solve it with simple machine learning. And so this is why I would not classify data science as being the same thing as machine learning. Again, if you're not familiar with machine learning, don't worry. But if you are familiar and have in the past conflated these two things, this is hopefully helpful. The second kind of follow-up point to that is that data science is not machine learning contests. So it's a great website. I really like, actually, Kaggle. I think Kaggle's a fantastic website. For those, actually, who here has heard of Kaggle? OK. Oh, fantastic. It's getting more and more popular. Great. So it was about half the class, I think, at least, and maybe the other half just weren't raising their hands. Kaggle is a website where you can go to. You can participate in machine learning challenges, essentially, that will give you a data set with some of the training data with the answer filled in, and then a test set where it's not filled in, and then you fill in your predictions on the unknown data. You submit it to the server, and you get a score back. Fantastic service. Has really kind of actually built a big community of machine learning enthusiasts online and really kind of accelerated the adoption and the appeal of machine learning in the public eye. But this is not data science. And the reason why is that data science involves the entire pipeline of collecting data, formulating a problem to begin with, solving that problem, and then understanding and interpreting the results and figuring out what to do. Kaggle contests occupy a very narrow slice of that. Basically, the given nicely curated data, how do you solve a particular problem? Not how do you define a problem, not how do you come up with that data, but just how do you solve this one problem. And so this is a very limited slice of what data science is, and I think it's often gets a little bit too much emphasis in the entire data science pipeline. Though, of course, as you can probably also tell from the schedule of this course, there is a big emphasis on machine learning even in this course. So data science really is this iterative cycle. Now, I should be fair to Kaggle here. Kaggle also understands this fully, and they actually have other portions of their website where they have more sort of free-form data set notebooks, and they call them kernel notebooks. And these are much more like the type of data of data science we're going to do in this course. But what people think of as Kaggle, of these contests, is really not data science. The next thing is statistics. And I'm claiming data science is not this either. Actually, I think this is actually probably the closest fit, though, to be fair. In fact, the department here just renamed themselves to be the Department of Statistics and Data Science now. I guess also acknowledging they're different, though, in some ways, right? They have to be acknowledging that as well. And so you might sort of step back, but say before these terms adopted their own meaning, I defined what data science was, and you would say, analyzing data computationally to infer properties of the real world, that sounds an awful lot like statistics there. And I think that's actually right. I think the differences here are more minor and more kind of philosophical. So there's two things, really. The first is that statistics as a field, at least academically, has evolved much more along the lines of kind of theoretical works. They're much more concerned about asymptotics, kind of the efficiency of estimators, stuff like this. And at least in this course, and in my sort of perspective on data science, I really don't care about those kind of things. Again, as a data scientist, not as a researcher. And this is also kind of evident in the fact that a lot of the tools that data scientists use are kind of a little bit more built upon techniques from computer science. Right, so it's a little bit more computational in nature. And for example, there aren't many statistics courses that I know of that have lectures on things like web scraping or even things like storing data in relational databases. There probably are more now that statistics is moving over to also be statistics and data science. But there weren't at least a little, maybe 10 years ago, right? That was much, much less common. And of course, the last difference is that statisticians use R as a language, whereas data scientists use Python. And that's just a fact of life, and that's non-negotiable. So. Moving on. I'm okay with, I think I caught my microphone there, but I think I'm okay. All right. The last thing I'll say is data science is not big data. That's hopefully pretty obvious, actually. For a long time, NSF, the National Science Foundation that funded a lot of this sort of academic research, lumped data science in with their big data initiative. And that was very odd to me because it seems very strange. So they would sort of say things like, oh, big data, data science, those are the same thing. So probably no one would make that mistake here, but at least people have in the past. So I want to clarify, data science does not need big data. Sometimes to make predictions or to understand your phenomena, you really do need to work with large, vast amounts of data. But oftentimes you don't. The standard for most data science is still work on a single machine with what you can store locally in RAM, right? And don't make more work for yourself if you don't need to. If you can store all your data in RAM on a single machine, even a big machine in the cloud, don't worry about Hadoop and MapReduce and these things. It's just going to cost you more time than it will actually save you. OK, so data science then, the way, I guess, back to what it is, I'm seeing data science here as kind of the entire pipeline of going from data collection, processing, visualization and exploration, analysis and machine learning, and then finally insight and policy decisions you might make from this. But of course, what data science actually is it's kind of this feedback loop where we're constantly using results from later phases and feeding them back in to change our decisions and what we do at previous phases. Okay, so now let me pause for a second, actually. Are there any questions so far? This is all pretty high level, I imagine there. But excellent, that's a question already. What was that? What do you have against R? R is a fantastic language with the libraries. Okay. Oh, sorry. I have to always repeat the questions because they aren't picked up by the microphone. So the question is, what do I have against R? Boy, where do I start? I think R is, so where R really excels is in its library of tools for statistical analysis, right? So it has an amazing library of tools for statistical analysis. And so at the level of actually doing the analysis, it actually is quite a bit better than Python, though you can call R from Python. So in some sense, you can kind of do it interchangeably. As an actual language, though, as a language from a computer science standpoint, and I think Python isn't even that great from a computer science standpoint, but from getting things done, processing data, collecting data from unknown sources, surfacing decisions, making decisions based upon this data, basically integrating with, I mean sort of integrating with other pipelines that will actually take actions based upon what you do. There's no comparison. Python has a much broader ecosystem of sort of interacting with other libraries, and it isn't really comparable. R is kind of a kludge to do things like that with. Again, this is my perspective as a computer scientist, but this is the perspective of most computer scientists, and we're in the computer science department here, so this is my stance. You can't use R for this course, for instance, right? I'm doing the assignments in Python, and that's going to be sort of the way it is. So if things are, you can do everything, but a lot of, especially the data processing stuff, is much harder to do, I think, in R. Now, there are people who disagree because they know R really well, but I think fundamentally, the library support for everything but the statistics is just not nearly as good in R. At least historically has not been. But to be fair, about, I would say even 5 years ago, the majority of the machine learning community used MATLAB for a while, so we did not have a good history of picking good languages. We were really making some mistakes. We've come a long way since then. I have a little bit more written about that on the course webpage if you're curious, but not much more than what I just said. Okay, so let's look at a few examples of data science. And these are the kind of examples that you could do for instance, in a final project for this course. They're quite, in some cases, the later cases at least, they're quite involved. They would really be a large amount of work, but they could be a final project for this course. So the first one I want to describe is actually a website that I really like this website. It's about gendered language in professor reviews. So I think about professor reviews a lot, as you might imagine. But let me show you this website. I'm going to go to the actual website here. This is a website that takes 14 million ratings from ratemyprofessors.com. It used to be more popular than it is now, I think. It used to be a little bit more popular, but still pretty well used. And divides up by different fields the number of times per 1,000 words that these terms are used to describe male professors and female professors. Right? And the results here are really sort of stark, right? Because these are from students. These are people they're trying to evaluate the professors. And they're frankly trying to do it in, I'll talk about kind of the positive terms here they're using to describe. So one of the ones that the site will actually go to, and this site, it's just the last bit you can ignore. There's also a link in the slides. This shows the word funny for describing a professor on ratemyprofessors.com, use versus from male and female faculty. So as you can see, there's a huge gap here. And people again, I don't want to infer too much from this because it's not actually making inferences, it's just presenting the data in some sense. But what the data shows here is that per 1,000 words, people use the word funny when reviewing male professors a lot more than female professors. And these are sort of positive things, right? And The results here are really stark. So this site was mentioned in a training seminar on unconscious bias that we do in the department here, and there are a lot of similar things or similar effects that come up. So on the other hand, a word like caring, which again is a positive word, has typically the opposite split there. So in general, in this data set, there's a much higher rate of using the word caring to describe a female professor than a male professor. And these are students reviewing these things. These are people that are trying to evaluate their faculty from an objective standpoint. But these biases that we have are nonetheless coming through. And to me, at least, a site like this, I have to say, is much more compelling than even some study documenting the exact same thing. Even though I know the study is actually much more rigorous and has much more controlled experiments, this is kind of impossible to ignore because it's so simple, right? You sort of can't, it's just the data. It's not any inferences, really. We're not saying there's some p-value here or which this is more significant than that. We're not saying any of that. We're just saying look at the data. This is what it says. And that's a really sort of great thing that data science can do really well. So the other thing I'll say is that this is an incredibly simple example here. It's not doing anything. There's no predictions here. There's no machine learning here. There's really nothing. But this would be a fantastic final project, for instance, right? This would be a great final project. You can't just do it now that it's already been done. But something like this, right? You have to build upon it at this point. But something like this would have been, at least, a fantastic final project. So this is due to Ben Schmidt, who's a faculty member in history, I think at Northeastern. Hope I got that right. Anyway, the link is on the page. And one sort of obligatory quote you have to say in every, oops, what's happening here? Oh, okay, I'll just move it on. Oh, I have to get off full screen. Do you know how they sort the y-axis? The y-axis is sorted by total occurrences of that term over the different fields. So it's the average of those two things. Yeah, basically the average of those two things. It's not going back. Okay, there we go. So the obligatory quote here, I think every data science course has this quote somewhere in it. It's from John Tukey, who's a famous statistician. He says, the greatest value of a picture is when it forces us to notice something we never expected to see. And that, I think, is actually a great example here of sort of the power of things like data science here. Okay, let's talk about another example. This is a slightly more involved example, and this is 538, which made forecasts of the election. So hopefully it's not too bringing back memories to people, right? Anyway, so there are two. So 538, for those that don't know, is kind of actually a general site now about analyzing all sorts of things, sports and politics, all this kind of stuff from data. But they're most famous for their election predictions, right? And in 2012, they were hailed as being the future of all political discourse because they got everything right. They actually happened to predict every state in the election correctly, but correctly is really odd here. It means they assign a probability to each possible outcome, and all it means is that there was, for the things they had greater than 50% chance of, all those events occurred, even though, by their own model, that would have been an unlikely outcome to actually happen, right? So there's a lot of randomness involved here. But the narrative in 2016 was that they, and I should say, every other forecaster, right, got it wrong somehow, right? Just about every sort of, well-known political forecasting outfit here predicted that Hillary Clinton would win, and of course Donald Trump won the presidency, right? And so the sort of the next public take on this was that, oh well, these things just aren't working anymore. And so there's sort of 2 points that I kind of want to make on this. The first one is that these kind of applications, they're still pretty simple, but they are a little bit more involved than just the previous one because now they're making predictions, right? We're actually talking about making predictions about what will happen, not just what the data looks like. I think if they were pitching themselves as, here is an average of current polls, they would not have, and there actually were outfits that did that. They do not take as much heat from the public as for just averaging polls as you do when you start saying, I'm making predictions, right? Predictions are a tricky business, especially about the future. That's a great, I forget who that quote is from, but it says, I never make predictions, especially about the future. So this is the assumption that's right. So the first thing is this is a much more, in some sense, complex thing, even though the actual methods here are still pretty simple. They were basically just averaging polls with some additional factors sort of thrown in terms of how they weight the polls by their past accuracy and their methodologies, and also how they also include a little bit of other meta information in one of their versions, like the economy and stuff like that, right? But it was pretty simple stuff. That's point one. As a data science problem, this is a little bit more, project is a little bit more involved. Point two is that even though they got it wrong, right, they were assigning a pretty reasonable chance to Donald Trump winning the presidency, 30%, right? If you have one off event and you say there's a 30% chance of something happening, if you're a statistician, you think, okay, that happened, that's slightly less likely, but still perfectly plausible given their model here. And despite constantly trying to hit people over the head with this before the election and say, yes, we think these are just probabilities here, that was not the narrative that took place right after the election. The other thing they did, which is actually really important, is that they realized that the errors in state polling were going to be correlated too. So every state, especially the ones like Pennsylvania and Michigan and Wisconsin that ended up going for Trump, they were showing polls that sort of indicated that Clinton would win, right? But what 538 kind of assumed in their estimates here was that if those errors in those polls were going to be correlated. And by modeling that probabilistic correlation, they actually had assigned a much higher chance of Trump winning than most other competing forecasters. And so I would actually argue that they actually kind of validated their methodology to a large degree during the last election, because the polls all were, in some sense, a little bit wrong. And so they really kind of had the right methodology about how you handle correlations in these unknown things. And so I view them actually being quite successful here, much more than the ones that say there was a 95% chance that Clinton would win, certainly. And I think that that's been completely ignored, though, by the public. And so the final lesson is that people have a very hard, no matter how many times you say it, people have an incredibly hard time understanding probabilities. And conveying probabilistic forecasts to people is an incredibly hard task. So there's not just the prediction problem, there's also the problem of conveying your results. And even a well-funded outfit, well-funded and sort of really very, very well-polished outfit like 538 had a really hard time doing that. Okay, so let's move in a little bit more in the spectrum now of more and more kind of involved and challenging data science problems. This is the last one I'm going to highlight here. It's a problem that deals with poverty mapping. So the way this evolved is this charity called Give Directly wants to give out cash donations to villages, I believe in Uganda and Kenya. And they want to give these donations to places that need them the most, right? That makes the most sense. If you're going to give some amount of money, you want to give it to people with the most need. And so they wanted to get a sense of what were the actual poverty levels in these regions that they were interested in, right? On the different villages, which ones actually needed it the most. And what they found was a very good indicator of relative wealth in these countries is the roof type people use. So when people get money, they put a metal roof on their house because metal roofs last longer. It's actually a good investment because the thatched roofs have to be replaced every so often. Metal roofs incur a big upfront cost, but once you have them, they last for a very long time. So they're actually quite efficient and make good economic sense to buy when you have them. So when people are a little bit wealthy, they put a metal roof on their house. And so what they did here, in order to assess wealth on a broad scale, is that they used satellite imagery of these different locations and built machine learning and really computer vision classifiers that would detect the thatch roof huts. You can't quite see it in them, but if you look at the slides later, there's some thatch roof huts there, and then metal roof huts in the satellite imagery. And so by looking at this, they can both get a sense of the population density, the number of houses there are, and again, relative levels of wealth in these different regions. The way they did this, they built a little site where you could go in and manually label them, right? So they built training data by having people label these things manually. They then built a classifier which would classify, both detect houses and classify them as having a metal roof or a thatch roof. And then they used that to build a heat map of what percentage of roofs have metal versus thatch huts, and they use that to target their donations to the areas with the most need. So I think this is actually a really, really great application. It's been, I should say, extended a lot. Stefano Armand and his colleagues at Stanford have built a lot upon this and used much more involved techniques to predict wealth. So not just thatch hut roofs, but actually they essentially use machine learning classifiers and things like night visibility, which tracks how much light there is, to predict the overall wealth of an area. And they use much more sophisticated computer vision techniques based upon deep learning than what they were doing in this study here. But essentially, there's been this whole line of work now on using aerial imagery to understand demographics of populations, which is a great sort of use of data science because we have all this aerial imagery. We should be using it for something other than just, building maps and stuff like that. We can use it for so much more than that. The same goes for things like Street View, by the way. There's actually just recently a really nice article in the New York Times about a project also at Stanford from a different group about how to use Street View imagery to detect the overall demographics and wealth of a population as well by looking at the cars that are in that area. So there's really interesting ways and clever ways of using large amounts of data in that case, and in this case, pretty sophisticated machine learning techniques to accomplish something really impressive from an understanding standpoint. And hopefully that does kind of show the spectrum of possible ranges of data science, right? It can span from just really counting words and presenting them in a clever way that kind of makes it unavoidable, the things you have to notice, to very complex machine learning pipelines that quantify complex characteristics like wealth based upon other data like satellite imagery. So that really is the spectrum of data science, and I think having that full spectrum is part of what makes it such a fun and compelling field. Okay, any questions? 'Cause I'm about to get into the more boring stuff here. So any questions about this interesting stuff before? Yeah.
Is it not just data analytics and the data science part comes later in the second, both the second and the third example?
Okay, so the question was, in the first example, wasn't that just data analytics? I'm not going to differentiate between those two terms in this course, is I guess my first answer. I think when you start getting too fine grains there, then anything can be, right? Then you're drawing boundaries too fine here. What's analytics versus data science? I think it's a very kind of, it's not a well-defined question, except maybe on how you would present it at a business meeting, right? If you want to call analytics one thing and call data science something else. I'm going to put it all under the rubric of data science and be accepting of that, basically. So I have no problem calling, scraping a lot of data, processing it, formatting it, and then displaying it. I have no problem calling that data science. Yeah. Yeah, so the question was, are data mining and business analytics, business what? Business intelligence, are those also part of data science? Yeah, I think as with all these things, these terms have huge overlap and also some specificity to them. So business intelligence oftentimes means more corporate related, right? Data mining, that one is pretty similar to data science, honestly. That's kind of just a different terminology, but oftentimes, for whatever reason, has evolved more about involving more network science often, but that's entirely maybe the fact that Christos Faloutsos here does both of those two things and is the biggest person in data mining probably. So I really think when you start splitting hairs there, if you have to define one, what's the difference between business analytics and data science, you start making up distinctions that aren't really there. I don't want to differentiate. That whole thing is data science to me. If business analytics covers some of it, that's great. If it doesn't cover other parts, that's also fine. I would say that things like business intelligence can mean just looking at an Excel spreadsheet too, right? It can just mean basically looking at 5 columns in a sheet and saying, here's what happened. And I wouldn't really call that data science. So there has to be some amount of computational work to really be data science, I would say. And if there's no algorithmic work, if it's just sort of looking at 5 numbers and making a prediction, or assessing how healthy your business is, I wouldn't call that data science. Okay, so for the next half of the course, or not the course, lecture, we're going to talk about the sort of the more logistical aspects of this course. So, first of all, the learning objectives. It's good to list these things always for the course. So the objectives for this course are still kind of pretty broad, and hopefully you can kind of get a sense of these things just from the topics I've talked about so far. But after taking this course, you should kind of understand this full data pipeline as I've defined it, and be familiar with kind of the programming tools of each part. Right? You should be able to collect data from unstructured sources, store it using the appropriate structure, such as relational databases, graphs, matrices, etc. You should know how to explore and visualize your data. And you should be able to analyze your data rigorously using a variety of techniques from statistics and machine learning. One thing I will say, as you can kind of see from this next slide, I think some of these actually might be, I think I actually took out one of those, so I might change the slide in a second. This sort of, I kind of have 3 main categories here. The visualization is kind of split in the course. It's not quite organized like this in the course. The course is really organized into data collection and management, then simple statistical models, then a little bit more complex models, and then kind of a variety of other topics, including more advanced visualization, as well as things like data science debugging and stuff like this, which is actually a kind of a core principle of data science. But these are the kind of the topics that we're going to cover. Again, subject to some change. I think some have already changed a little bit, so this is already a little out of date. But the list of lectures is on the website. Now, the philosophy of this course is that we kind of want to do 2 things, though. I kind of want to do 2 things. I want to present you with the tools that you use in practical, as the name suggests, in practical data science work, which is, frankly, oftentimes you're going to be using libraries to analyze your data, right? But what I've found, sort of personally, and I found this in a lot of different settings, is that the better you understand how these things work, the better you're able to use these tools. So if you don't know how even a basic machine learning algorithm works, it's very hard to use libraries like scikit-learn. You don't have to know how all of them work in their most sort of fine detail, but if you don't know sort of the basics of how to implement a simple machine learning algorithm, it's very hard to use more advanced tools. So what we're trying to do here is we're trying to kind of give you a little bit of both. Teach you some of the tools and use some of the tools that exist out there that you would use, say, in a data science position, but also teach you a little bit about how they're implemented internally and how these might actually work. And this applies specifically, especially so, to the 600 level of this course. I'll talk about the difference more in a second. I think that's actually the next slide. But especially, I mean, a little bit in the 300 level course, but especially in the 600 level course, you will actually need to implement and build some of these tools that will later maybe not implement yourself, but just use. You will actually need to implement them on homeworks and through the course. And so, for example, I sort of already said this, but we'll teach you how to use the scikit-learn library, but you'll also need to implement some machine learning algorithms yourself. And so you will have to know a little bit about how they work underneath the hood. Again, because I personally think that these things are very hard to use when you don't understand anything about how they work internally. All right, so the next sort of item of business would be the difference between these courses. I guess, sorry, this is between these courses and other things, not between the 2 courses. That comes later. So the differences between this course and you name it, right? CMU has no lack of courses that cover topics related to this same course here. And in some sense, this course came relatively late in the game. And so it is, obviously taking content then, not directly, but taking using the same ideas as content in a lot of other courses. And that includes things like the machine learning courses here, some of the LTI courses, a lot of the stats courses, and many others. I don't even remember what all those numbers stand for anymore. Those are just some examples of course numbers you can look up to know things that are similar to this, or things that have some overlap to this. So people often ask me, I've taken 601 and 701 before, will I get anything out of this course? And I think yes is the answer, but you have to decide that for yourself, right? So What I will say is that compared to other courses, this course does focus much more on using these tools to address real-world problems and sort of not problems, but real-world data and kind of real-world data in all its messiness. So we're not going to always just give you clean. We will sometimes by the end, the last assignments, assume you can do the first bit. But at least initial assignments, we will give you kind of messy data as it actually exists, and you'll have to process it. You won't get kind of a clean data set you can just run a machine learning algorithm on. You'll need to actually be doing some actual processing and kind of work with data as it really would appear in the real world. Now, on the flip side, compared to the other ML or stats courses, there's zero theory, essentially. I mean, I will present some math, actually. I will derive some algorithms a little bit, but you don't have to do that on the homeworks. The homeworks are going to be about implementing these things and kind of using them. The math is so that you understand it, but it's not about what you need to do for the homeworks themselves. So that's not the focus of this course, is not the math and not the theory sides. So that hopefully gives some understanding of what it is. The reality is you should just look at the topics, look at the first homework, see if these are things that you want to keep doing. In terms of the background, there's not much by the way of formal prerequisites because this course gets people from a lot of different subjects, right? A lot of different departments students from different departments take this course. And even for the grad version, we don't really enforce prereqs anyway, so there's almost no point in having a long list of prereqs you have to take. For the undergrad course, you do have taken an intro to programming before, but that's really the only formal prereq. Now, having said that, I would strongly recommend that take this course, you have some experience with Python already. It is possible, if you know other programming languages, it is possible to learn Python while you take this course. It is not advisable, though. It will be hard, and you will work a lot more than the 9 and 12 hours that we're aiming for CS students that were taking this course, right? So be warned about that, right? It's also beneficial if you have some amount of experience in probability and statistics and linear algebra, though the last one especially, hopefully, or rather not hopefully, but we don't do too much linear algebra, but still, if you've seen it before, it's quite useful. And this is really just at the level of maybe inverses of matrices, nothing more than that. But understanding matrices and inverses is useful because a lot of data is often stored in matrix form, and we think about manipulating data in matrices a lot. If you don't have a background in these areas, you can still sign up, certainly. Just know that it's going to be possibly more work. And the general rule of thumb that I try to go by here, which I think is really useful, also thinking about really any kind of work that you're doing in your life, is if you're starting the homework and it seems hard, but you know how to, or at least you have an idea about how to proceed when you get stuck. Not always, but maybe you have to ask TA sometimes. But if you have an idea about how to proceed when you get stuck, that's probably a good level of difficulty. If you never get stuck at all, maybe it's just too easy, right? If everything's so simple, then you might not be learning that much. If you find it a little bit hard, you have to figure things out, but you know how to proceed, that's good. If you get started and have no idea how to proceed, even what the first step is to do, that's a good sign that the course is a little too hard. I shouldn't say too hard, it's just you don't yet have the background for the course, right? So look at the first homework. It's going to be out next Wednesday, actually. I was going to be out next Monday, but I think I really wanted to cover the third lecture before releasing it. So it's going to be out next Wednesday. Look at it when it's released and see if you feel that you're in that category and not in the category of, I have no idea how to even get started here. Because I should say the first two problems listed in the first homework, which are the 388 ones, those are a little bit easier than most. So if those are hard, it's a good indication that this is probably a little bit too much. All right, so that's sort of the course. I guess I broke it down somehow into course objectives and topics and the course logistics. I'm not quite sure the differences actually, but a few more things to cover now. And this is even more. Maybe this is even more dry and boring than the last one. So that's sort of the difference. But yeah. Okay, so the question is, are we going to use any big data tools? So we will have a lecture, ideally two, but definitely one lecture at the end of the course on essentially MapReduce techniques and big data techniques. Now for the homework, we won't be required to write code in, say, Hadoop, mainly because it's really a hard thing to get the a Hadoop MapReduce setup working on our autograder that we use. What we will do is we will actually use essentially our own very small MapReduce framework, and you'll have to implement known algorithms that you sort of already can figure out in the single machine case. You'll have to implement them in a MapReduce framework. So we will do that. But it's not the focus of the course. The focus of the course is more the entire data science pipeline, big data being an important but small piece of that. And we are going to be focusing on kind of this MapReduce framework for that lecture and for the homework assignment. Yeah. Yeah.
Is it possible to switch between the grad and undergrad section?
Yeah. That's great. I will actually answer that in a question, but the short answer is yes. I'll get to that in a second. So the question was, can you switch between the grad and the undergrad versions? The answer is yes. I'll cover how that works in a second. All right, so first of all, let me introduce the TAs of the course. Not all of them are here right now, but actually if the TAs are here, can they stand up? I see one more at least. So these are the TAs that are here. There are a few more as well. We might actually add a few more in addition because we have 9 right now, really 8 because one's just an honorary TA. He was TA last year, and so therefore he's forever TA going forward. But the TAs here, they'll be holding office hours. They'll be answering questions on Piazza. I'll get to all that in a second. And they'll be, you know, a main contact point of the course. So I'm sure you'll get to know them all a lot throughout this course. So thanks, guys. All right, sort of chugging all along right now. The course material is all available on the website. So the website is datasciencecourse.org. I actually have. Let's see, I have it displayed here. All right, here's the course webpage. The important link that you're going to go to a lot probably are these two, the assignments and the lectures. The lectures have all the lectures. In addition to the lecture, you can download the slides for the course. So the slides are in PDF form. The notes, along with these lectures, there's going to be sort of some notes along with it. That is the only textbook. There's no textbook for this course. It is just the written notes that we have here. So this written notes here has a sort of a little prose description about what we just talked about, at least not the logistics part, but everything else. And the last thing it'll have is we're also recording video, which I'll get to in a second, and I'll talk about sort of how that will work, and a quiz. I'll mention what that is in a second. That actually mainly applies to the online, people taking the online only version. So if you're in section B, there's little quizzes which are very short. They're just meant to make sure that you actually watch the lecture. And we'll get to that in a second too. but they're very, very short. And we'll actually post it after class too, because I want to make sure I actually talk about everything that I'm going to ask you about. Okay, so this is sort of the main page you'll sort of deal with. There's also an assignments page. Once we have homeworks out, they'll be posted here. Assignments are all going to be submitted through Autolab. A link is here if you need it, but it's just autolab.andrew.cmu.edu. The course has been set up in Autolab, but you are not added yet. I think we can add you so the TAs will add you shortly. Until the homework is posted, it doesn't really matter though, so we'll add you before the homework is posted. And then there's instructors. If you forget who we all are, you can see us there, and frequently asked questions. And then also there's some info here if you forget where the course is or anything else. Okay, as I mentioned before, the slides, well, I guess there are videos, but slides, I will try, I have to have them for class, right? So I'll try as much as possible to post them before class. I hope a little bit more than before class, but I do sometimes work up to the last minute. We procrastinate too as professors. It's a universal thing. I do work on them until the last minute sometimes, but I'll post them before class at some point. Videos will be up usually 2 to 3 hours afterwards, but and I'll try to remember that. Sometimes I forget to post the link right afterwards. There's also there will be a permanent link to the folder on Panopto, which is going to contain all the lectures, and that will always have them essentially immediately after they're submitted and recorded. They'll be there, or at least after they're processed, they'll be there, so you can use that. And then the notes, I really hope I can get them up before class, but that might not happen. And if I'm really straining, I will defer those until make sure the lecture goes on okay with slides, and post the notes after class. That was very, very high probability that happening at least a couple times over the semester. So that's the likely schedule of these things. We'll talk about the schedule for the homework in a second too, but that's the schedule for sort of the class material. the discussions for the course, and most of your interaction with the TAs, I think. There will be office hours, which we'll post also later. We're finalizing the schedule. But the class discussions will be handled on Piazza. So on Piazza right now, as listed under 15388/688, you can enroll in the course. Everyone needs to do that within a week from today. And in particular, the threat I'm going to use is that if you're not enrolled in the course with your Andrew ID, you can actually have multiple emails. So as long as your Andrew ID is one of the emails you have with your Piazza account, unless you do that, we reserve the right to kick anyone out of the class that has not yet signed up for Piazza a week from now. It takes 2 seconds. You can do it right now. Just go ahead and do it. We're also actually going to have in-class polls that use Piazza. I'll talk about that a little bit more in a second, but you will actually need to have some way of using Piazza in this room. So either bring your computer or your phone. Both work just fine. All right. OK, so now the 688 question. So the courses, as you have obviously probably realized, are the same. They have the same lectures, the same assignments, and the same sort of requirement of a tutorial and a final project, which I'll, again, mention more in a bit. The difference, though, is that every homework assignment, of which there are 5, the 688 version will have 3 questions, and 288 version will have 388 will have 2 questions. 688 will have 3 questions. So you have an extra question, and substantially extra from 2 to 3 in the 688 version. And these are exactly what I said before. They typically go a little bit more in depth into implementing the algorithms behind some methodology or technique, and that's going to be in the 688 version. Now, undergrads can take the more advanced version. That's completely fine. And master's students that would get credit for it can take the 388 version too. They're both allowed. All I will say is wait, and we can do the switches after the add and drop deadline. We're going to wait until after that. So that's, I think, January 29th. We're going to wait until after that, basically until the course registration shakes out, to officially switch people over. It's kind of a pain, but it's much easier because otherwise, the course sizes have to be adjusted accordingly. It's a total pain. So we're going to wait until after that to actually do the switches. If for now, if you want to, as an undergrad, if you're in 388, you want to take 688, just start doing the assignments, the more advanced assignment in the assignment. Or if you're in 688 and you're going to switch, and you can get credit for it, just don't do the assignment, I guess, and then you'll switch later, and then you'll get full credit there. So you definitely can switch. I would encourage anyone that wants, an undergrad, if the first 2 questions just seem a little bit too easy, definitely take the more advanced one. If you're a master's student, maybe from a different department, and you just seems too hard the last question, then you can drop down to the lower level. Okay. Okay, so the other thing is the wait list. So there are currently way more students enrolled in some version of the course, at least, or on the wait list than we have available space, even in Rashid. So to allow as many people into the course to have official slots as possible, and also actually so people in the Silicon Valley campus at CMU can take the course, we actually have an online section too. And section B is an online only section. It means so it's called a DNM section, does not meet section. And again, they're exactly the same, except that the lectures are all online. So you technically are supposed to watch them all online. Now, I will say, and I don't think there's any chance of me being wrong here. Even today, it's not awful. Right? Maybe some people turned away at the end there, but I don't think that many people did. If you're in section B and you want to come, you can come. That shouldn't be on video because I'm not allowed to say that actually. Sort of feeling discouraged, but you can come. It's going to happen that people, people don't want to attend lectures, so they're in the A section right now and they switch to the B section because they'd rather just watch the videos at home. I've never had it I've never had a course that by the end, even by the third week of class, when it's this full at the beginning, it stays this full, right? So people people will drop. People will see the first homework and say, yeah, it's not really my thing. If you're in section B and really want to come, you can come. Okay, so don't let it be an impediment to coming. I'll talk about, but what I will say though is if you are in section A, you should come. Class attendance actually is required there, and I'll talk about how we monitor that. So if you don't want to come, then enroll in Section B course, Section B version. You can actually only do that as a grad student, though. There's only the 6088 version. There's no 388 Section B. That's a requirement of the university, actually. So know that. But if you're in 388 or 688A, class attendance is a part of the course. Now, about the wait list, will you get off the wait list? For this one, if you want to take 388, yes, you probably will. Again, certainly if you're an undergrad, you will. It's not full of undergrads. If you're a master's student that wants to transfer down, if we get a lot of those, it might be a little dicey, but we'll try to make that work still. For the 688A section, probably not, at least not before the add deadline. You definitely could probably add afterwards, because I know people will drop after that point. But I wouldn't bet on it before the add deadline. And Section B, yes, you can. There's some weird thing where currently even people on the wait list are not being let in. But if you have units, enough units, or you have enough free units, you should be able to get in. It's just a matter of the people clearing you one by one. So we do that every so often, and this should happen relatively soon. Or you should get an email saying you can't enroll because you have too many units or something else, or you have a conflict, so therefore you can't do it. But if you don't meet that criteria, you should be able to get into the course. There's a question there? Yeah. Yes. Yeah. Okay, so the question was, I mean, this is sort of specifically, but someone was on the waiting list here, tried to add there. Did you drop the wait list for this course? Yeah, so don't worry about the priorities are actually meaningless. The priorities don't mean anything. If you're in the A wait list, you have to drop it before you can enter the B course. All right, so we don't add in the order of priorities, even that's just like a listing of a temporal listing. We don't add actually in that priority. So don't worry about that. You will probably be able to, if you want to later switch back into the A section, you probably can, but probably not before the add deadline. So do the B section for now, get in the course, and then switch later. Yeah?
I'm an international student, and I was told that I should choose no more than one online courses per term.
Yeah.
And now I already have an online courses, and I don't know if I enter the B section, is that like measureless?
Yeah, so the question is, so some students, international otherwise, have limits in the number of online courses you can take. It's hard to say. We can't really. It's really hard to give priority just to those students that are in that situation. The reality is, if you're able to enroll in the B section, do it and just come to class, and then you can switch to the A section eventually anyway. I promise that all this works out. There will actually not be a full course by the end of the semester in terms of either of the sections. So it will work out, but you may have to bear with us for a little while. The registrar does not allow you to overbook a class, despite statistics telling you that this will work out every single year. They will not let us do this. So we have to kind of have these tricks to get around it. And so these are the tricks that I shouldn't say this on video, but it's the tricks we use. Especially not like public video, right? Which I'll get to in a second. Okay, yeah.
Are there examples of homework that
yeah, so we'll post the homework very soon. The reality is we're using most of the same homeworks from last year, so actually the last year's course has them. I don't actually want, up until recently, actually the web page was up. You could probably find like an archived version of it somewhere if you really want to. I'd rather not post the homeworks that much, but if you are curious, I can maybe offer a link to like the homework 2 or something like that, just so you get a sense of what it is. I'm nervous about people getting daunted by seeing it too much before you've even seen the lectures, right? So, but we could try something like that if there was enough interest. I'll think about that and try to post it. Sorry, again, I always forget to do this. So for everyone watching video, you can't hear the question. So the question was, can we post a homework from last year to get some sense? We can probably do something like that, yeah. The first homework will be out before the add deadline, though, so you can drop or add as you want based upon that first homework. All right, next up, course videos. So as I mentioned, there's going to be videos available for all the lectures. They will be posted on the course website as well as a permanent link to all the videos because I often forget to link each individual lecture after class. However, attendance still is required for Section A students. So if you don't want to attend the course, then enroll in the B section. That will also help shake out the list a little bit. And I'll talk about the different requirements for the different sections in a second. It basically boils down to how you fulfill your class participation grade in the different sections. One important note is that videos are publicly available. So actually, they're available to anyone. So they're recorded via Panopto, but they're going to be set to be publicly available. That means anyone can watch them. It also means that if you sit near the camera, or maybe, I don't know if you can see the first row of people, the back of your head might be visible in the video that's posted online. So just be aware of that. Also, you will not, however, be in much danger of your voice being picked up, maybe unless you're really loud in the first row. Even for the students that are in the online section, I try to always make sure to repeat the questions because you can't hear the questions at all on the video. So I will try to always repeat them. What that means to you is that you will not be recorded or not in any sort of notable way. You have to do some audio analysis to hear you, I'm sure. But you will not be able to hear yourself in the videos. But know that they are publicly available. And we're doing this from the beginning of the course this time, so just be aware of it. OK, let's see. Next, OK. Last thing, and I'll go through all of these now in some detail. But this is the grading breakdown for the course. So the grading breakdown will consist of the homeworks, a tutorial, a class project, and class participation. And I'll cover each of these four things in some detail now. The first thing, and probably the majority, or at least half the plurality of the course credit here comes from homeworks. Also, I guess it's on the slide here, but the grades will be assigned on a curve, final grades, and that will be done separately for the undergrad version and the grad version. But the same for the A and B sections of the grad version. All right, so homeworks. I'll go through each of those 4 points in some detail now. Homeworks there's going to be one homework, not quite every 2 weeks actually. They're actually there's 5 homeworks for the course, and you have 2 weeks for them. This is actually, we cut down. We had 6 homeworks last time we taught it, but I think it's a little bit too much. We're doing 5 homeworks this time. They're going to be released on Wednesdays, and then due the Wednesday 2 weeks later. And that will, as much as possible, try to stick with that. We may miss the deadline sometimes. As I say actually I mentioned this, I didn't put it here, but I put it on the assignments page on the website, is that our rule of thumb is that we will have, so the homeworks are all auto-graded, which I'll talk about in a second, but the homework will be posted by midnight on the day that it's out, or 11:59 p.m. So if it's Wednesday, it's released at midnight, the night of Wednesday. The assignment is due at midnight 2 weeks later. So the deadline's always midnight Eastern time. And the auto grader for the course, for the assignment, will be released within 48 hours of the assignment being posted. So it is possible that you will just have the assignment at first. You will not be able to submit your assignment to be graded. But within 48 hours, we'll have that auto grader up. If we ever slip with that, which we might sometimes, we will extend the deadline on the other side. We can't do that too much because then they start conflicting. So we're really going to we don't want to do that ever. We have most of the auto graders from the assignments last time, so it really shouldn't be an issue. But if it does happen, we will shift the due date accordingly. If there are bugs in the auto grader, if they are major bugs, we may have to adjust the deadline as well. If they are minor bugs, though, those do happen, and they are part of an evolving course. This is the second time we taught it, so there should be much fewer than last time, but still likely some. And so we will hopefully not have too many. If they are egregious, we will shift the deadline accordingly. If they are not egregious, we will thank the person that found the bug. If you do a lot of this, or you're very diligent, you can maybe even get class participation points or some little bit of extra credit for that. But there's no sort of set thing there. Hopefully, it won't be an issue. It won't happen. The homeworks are all, though, done in the form of Jupyter notebooks. So they are, people that are familiar with, we'll cover Jupyter in a second, but it's essentially a notebook where you write code and text, intersperse it with loading data and stuff like that. And the homework essentially all come in the form of a template, Jupyter Notebook, which you then write the appropriate code for different portions, and you can test it against some small test cases, and then you will submit it to Autolab, and Autolab doesn't actually evaluate your code except that it runs tests against it. So everything here is going to be auto-graded. One of the challenges of scaling a course like this to the size of students we have here is the challenge of scaling it. Actually, I have a whole slide on this, but I should say that one of the goals of this course is kind of be a scalable and eventually even bigger than this introduction to data science. And the only way to sort of make that work, I think, with homeworks is through use of auto-grading. I think it's very hard to manually grade, especially code. To manually grade that many programming assignments is really kind of very onerous and would require many more TAs than we have. There's also some problems with it. It's not perfect, right? It does prioritize just some simple test cases over, well-structured code, so you don't get a lot of points for, having beautiful, succinct code with the most elegant algorithm, right? But the reality is that a lot of the work you do as data scientists will be judged on, effectively, on test cases. And so this is sort of, going to be the reality of a lot of code you write, and so this is what we do here. Having said that, there are two other portions of the course, namely the tutorial and the final project, that are not auto-graded. Those are, of course, written reports or written descriptions, and those we can't auto-grade, so those will be manually graded by myself and the TAs. And so not everything is auto-graded, but the homeworks are. They're really kind of programming-based homeworks. So it's a mix that's sort of not quite ideal. It'd be even nicer if we could have, customized one-on-one tutoring for every person to sort of look at your code and really walk you through it. But we can't do that. So in the efforts of scaling, we are going to be heavily relying on auto-grading. So you'll kind of get used to this through the homeworks as well. One last thing about the homeworks. Late days, assignments are due at, as I said, midnight on Wednesdays. Hopefully this is pretty standard for everyone, but the policy is you have 5 late days. Things happen, right? You have an exam on the same day homework's due. You just don't get started soon enough, so you need to push it later. You have 5 late days over the course of the semester, but you can use no more than 2 late days on any given assignment. That means they are due at the very latest by Friday at midnight. And after Friday at midnight, or after you've exhausted your 5 late days, you will start getting 0 points for the assignments. So it's much better to submit a partial assignment than it is to hold off on everything and just miss the assignment completely, because you get no credit then. It's just too much confusion when we start having about deductions of percentages after this. It's just 0% after you use your late days. And you cannot use late days for the final submission or the tutorial projects. It's just for homeworks. All right, the last component of the grade was class participation. So there's 2 sort of ways this happens. For the people that are in the in-person section, so section A people, as I said, attendance is required. And the way we take attendance, though, is there will be 1 to 2 in-class polls per lecture. So if people have used Piazza before, Piazza has a polling system where basically we publish a poll. I actually only open it for a very short period, so you have to be in class. I mean, there are ways of circumventing this, right? You can have like a channel that says like, well, all your friends just waiting for the, that they aren't in class, or they're waiting for the poll to open, but please don't do that. You have to be in class. You see in class that I'm opening the poll. You answer the question. The poll closes, and we see the results. Try to answer the question correctly, but really what we're going for here is not correct answers. It's just participating in the poll. You could click something randomly, but try to answer the question if you're sitting here anyway. Obviously, that does not work for section B people, because they're going to be watching the videos separately from this. We need some other mechanism. We have 2 here. First of all, we can track your viewing of the video in Panopto. So Panopto says how much you've watched of the video. So we will, by your Andrew ID, and so we'll make sure you've watched the entirety of the video through Panopto. And then there's also a short quiz you have to answer about the lecture. So you don't just play it and then leave it in another room while you go do something else. You have to actually watch the video. Again, it's just meant to sort of gauge just some amount of participation, not meant to sort of stump you. We're going more for doing it. But there, we actually want you to have a few right answers, because if you just fill it out randomly, you could just fill it out randomly. So you know, do try to do this. Again, as you can probably guess, there are obviously ways around this. If you really want to, you want to circumvent this, there are ways around this. But the lectures are an important part of this class. Even, I should say, if they are not exactly used to complete a programming assignment, they are things that you will hopefully be able to use on the project or on your tutorial, or just things that are good to know. So do attend and do watch them if you're in the B section. Part of our reason for making them do within a week of the lecture is just that people would otherwise tend to get kind of behind on lecture video watching. Even with the best intentions, they intend to watch all of them, but the semester goes along and all of a sudden you have a backlog of 10 videos to watch, and it gets very hard to catch up. So that's why we have the lectures. You have to watch them on Panopto and fill out the quiz within 1 week of the lecture. The quiz today I'll probably post after lecture, just because I want to make sure that everything that I have said or asked in the quiz was actually covered in lecture. It'll be 3 or 4 questions. It's quite simple. I think actually the TAs don't know it yet, but the TAs are going to be filling those out or making those for the most part. You will get additional extra credit for the class, for class participation, so you can get a little bit more than 10%. We haven't quite decided the exact form of it yet. For answering questions on Piazza, not for asking them, but for answering other student questions on Piazza. As you can imagine, in a big course, a lot of people are answering questions. It is very helpful if students take some of the load off the TAs of answering questions, if you know the answer. And if you think it's not something that gives away, obviously, if you feel like it gives away part of the homework, then don't do it. But if you feel like it actually it is reasonable to answer, we very much appreciate students helping each other out like that in a public forum, because then actually a lot of people can use those resources. I should also mention that you actually get negative participation. I really have to put this. I'll put this in the next slides. But if you ask a question on Piazza that has already been asked, you will actually get dinged a little bit on class participation. So you then have to make up by answering some other people's questions after that to make back up your part. So please do a search. I mean, if you really can't find it and you do it by accident and you realize afterwards, like, oh my God, yes, the TA responds with a link to another post that was the exact same thing you just didn't see before, fine. Can happen once or twice. If you do it a lot, then don't do that. Look at the questions before you actually post. Yeah. We will look at, in a very rough sense, of whether you're getting them all randomly or getting them approximately correctly. We don't care that you get them all correct. I just care that you're not answering them, filling them out randomly, and then leaving your computer on with the lectures playing, while you go do something else, right? So we're trying to avoid that. Again, there is a failure mode here that you can get away with it. If you really, really want to take this course and not ever see any material, you can probably do it, but it doesn't seem to be the right thing to do. So we put in at least the incentives to try to make you, force you to do it a little bit. All right, tutorial. Okay, the tutorial. So the tutorial is the philosophy here is the best way to learn things often is to teach them. And so in lieu of a midterm, we have a tutorial where you essentially write out an explanation of how to use some data science technique or library or other concept. It will be graded. It'll be in the form of a Jupyter notebook on a subject of your choice, but we'll also provide some suggestions. And it will be graded by the instructors, but also by other classmates. So you will grade each other's tutorials a little bit, and that grading will factor a little bit into your grade. Much more about this and the project will be posted when those are actually due. I want to hurry to make sure I get the last little bits. Class project. Class project is going to be sort of the final data science project of this course. It's done in groups of 2 to 3 usually. If you really, really want to work by yourself or in a group of 4, you have to get permission to do that. But if there's a good reason, we can allow that. There will be a final report, which will be a Jupyter notebook, working through the analysis of the data, including coded visual results. And it's also going to be presented in a video presentation that happens during the final exam time. So don't book your flight before the final exam. During that time, we will probably gather here and get some pizza and watch a lot of videos about people's data science projects, which is kind of fun. At least, yeah, I mean, until maybe the last, if it gets too long, I can get kind of droning on, but it's actually a lot of fun. I'll talk much more about the Clash project later, but it has to be focusing on a real-world data set. You can't just download a Kaggle data set and do it on that. OK, 2 more slides, and I think I'm done. Or 3 more slides. The last one, the first one hopefully goes without saying, but every year I always say, this is the year this never happens, and every year it happens. Especially in a big course, it does tend to happen, unfortunately. So I want to highlight the academic integrity guidelines that govern this course. The most important, really, is that everything you submit, that includes code, that includes text, that, prose that you write for your tutorial, for your final, everything has to be your own original content. Just being a tutorial does not mean that you can copy from text from something else as like part of going through it. And the goal is you're creating stuff here. It has to be your own content. You can discuss ideas and methodology with other students on Piazza or in person or at the office hours, but you have to write out your solutions independently. We will be running some amount of automated checking libraries to flag suspicious submissions. And so don't either copy from each other or copy code verbatim from elsewhere. If you do use, I should say a caveat for the last one, you are allowed to take small snippets of code from elsewhere. For example, if you find a Stack Overflow question describing how to solve some particular data transformation that you want to do, you can use that. But if you do that, you absolutely have to cite that portion of code separated by a clear indication of where that code is. Okay? So please make sure you do that. This is not a small deal. And it will result in, at the very least, a 0 on the assignment, at most, an escalation to the Academic Integrity Office. So please don't do this. And on that same note, actually, one thing I do want to mention is that CMU and environments like this and classes like this are stressful environments, right? And in my experience, most of the time, I've seen people violate academic integrity. It's not due to a desire to cheat or desire to not do work. It's due to being overwhelmed and, frankly, very stressed out. So please don't let it get to this point or much worse. If you feel like you are reaching this point, come talk to me or the TAs. Send us an email. Try to be reasonable in these situations. Don't let it get to something that's much worse. It's not the end of the world if you miss part of an assignment. All right. Up next, we're going to talk about data scraping and data collection. See everyone soon.